Hello, and welcome to this instructional video on the strategy pattern in software design. In this video, I'll be explaining what the strategy pattern is and how it can be used to improve code flexibility and maintainability. Design patterns are typical solutions to commonly occurring problems in software design. The strategy pattern is a design pattern that allows us to encapsulate a family of algorithms and make them interchangeable. Basically, we can split a family of algorithms into their own separate classes, our objects, which allows us to change out the classes, our objects, as we see fit. This means that we can switch between different algorithms easily without having to modify already existing code. In case you're rusty on the definition of an algorithm is just a set of steps or instructions to solve a problem. The strategy pattern consists of several components, including the context, the strategy, and the concrete strategy. Don't worry, we'll touch on all of these components in detail. Let's look at an example to illustrate how the strategy design pattern works. Suppose we want to create a program that simulates different cooking methods for preparing food. Each cooking method has its own way of cooking, such as grilling or boiling, etc. And we want to make our program flexible and easy to modify. The different cooking methods are the different algorithms, the different ways we can solve the problem, which in this case, cooking. We can use the strategy pattern to encapsulate the different cooking methods and make them interchangeable. Now, before we dive right into the code implementation, let's look at a UML class diagram that shows the relationship between the classes and the strategy pattern. If you don't know what UML means, it stands for Unified Modeling Language, and it's a modeling language used to provide a standard way to visualize the design of a system. I won't be going into full detail of that in this video. Basically, we'll be taking a look at the class structure. Here we have a context class, the strategy class, and the concrete strategy classes. The context is a class that contains a reference to a strategy object and uses it to perform some action. It acts as the interface between the client code and the strategy objects. The strategy class is normally an interface or abstract class that represents an algorithm. Different classes that implement this algorithm are the concrete strategy classes. They are the concrete implementations of the different variations of the algorithm. So in our example, the context could be a food class. Food can be cooked using different cooking methods or strategies. The strategy interface could be called cooking strategy, and it could have a method called cook. This interface represents the strategy for how food will be cooked. The concrete strategy classes are the concrete implementations of the actual strategies, such as grilling or boiling. These concrete implementations implement the strategy interface and have their own implementation for the cook method. Let's start off with the cooking strategy interface. It will have a single method, cook, and just to keep things super simple, we'll make it void. Next, let's create the concrete strategy classes. We'll have one for grilling and one for boiling. They both need to implement the cooking strategy interface and implement their own concrete variants for the cook method. Finally, for the context, let's create a food class. This class doesn't implement the cooking strategy interface, but has a reference to it. So now we can create a constructor that takes a cooking strategy object as a parameter and assigns it to the cooking strategy instance variable. This allows the food class to use the specified cooking strategy object at runtime instead of doing so at compile time, which allows for more flexibility. We also need to create a method that we can use to call the cooking strategy's cook method. In this case, I'll call it cook food and use the reference to call the cook method. Now in our client code, we can create different food and cook them however we like. With the strategy pattern, we're able to change out the strategies dynamically, so we don't have to go into already existing code and change the cooking style if we want something different. Let's add one additional method to our context, in our case the food class. Set cooking strategy. This method allows the client code to change the cooking strategy at runtime versus having to do so at compile time. When the client code calls this method, it passes in a cooking strategy object that represents the new cooking strategy to be used. So it replaces our cooking strategy instance variable in the food class with the cooking strategy object we just passed. With the strategy pattern, we're able to change out the strategies dynamically, so we don't have to go into already existing code and change the cooking style if we want something different. That is it for my instructional video on the strategy pattern. I hope you found this video informative and helpful. Thanks for watching, and don't forget to try implementing the strategy pattern in your own projects.